Welcome back to Math 2. I am geometry. Actually, I am ready to go surfing. I'm ready for lunch. I'm ready for summer. But we are in Unit 7. This is Lesson 4. All right, so let's get back to it, shall we? Okay, here's what we got. We got quadrilaterals. Quadrilaterals, four-sided figures, and our goal is to draw a circle that passes through all four of the vertices. In other words, a circle that hits point, point, oops, that's not a good point. Better point, 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 point. So we're trying to accomplish that. Now, you could probably think, yeah, I could do that. It's doable for some, but not for others. And I'm talking about the quadrilaterals, not students here. Square is pretty easy because we've done this. We've constructed it. It's been done. Now, watch me draw, because I'm going to attempt to draw on Doceri, which ain't going to be easy. So there's a circle, and it's not a good one, but it can be done. That can be done. You're wondering, where is the Chewy center? Well, there's a pretty easy way to probably figure that out. Some of you might say, well, we could connect the dots to the vertices, and right in the middle, those diagonals meet. So there is something going on here with the diagonals in the square. Somebody else might say, well, we could try making angle bisectors, because in a square, those angles are bisected because it's a square. So something to do with the angle bisectors. And in a square, that works. Then you go over to the bigger, badder monster trapezoid over here and say, can we draw a circle around it? Yeah, we can, I think. Freehand. Kind of like that. So it looks like it's possible. But if we go back to our other previous learning and we say, well, let's try and connect the diagonals. Connect the diagonals. Except, let's make them bigger and badder and better. Connect the diagonals. There you go. Does that look like the center of that circle? That is the question. Is that the center? That is a big question, because if we answer our own question, we'd say, no, it doesn't. It doesn't look like the center. The center actually looks like it's somewhere over here, somewhere where I can make a radius situation, and I can go radius, 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 equal distance. So that one looks like it can be done, but we don't know necessarily how. And then we move on over to the parallelogram. We say, can we do it again? We're 2 out of 3 here. We've done it. We've drawn a circle. We've looked at diagonals and their intersections. We've looked at angle bisectors, and that's a part of this too. Let's see, can I draw a circle that goes around? Looks like I can, but that's actually not very good. That one actually is not possible. I'd have to draw a better circle than that if I'm going to try that. So that one actually cannot be done with the parallelogram. I can fake it, but the problem is, here's the thing. Can I find a center where it's equally distant from all vertices? That's the question. If you can do that, that's what you're talking about for a circle. This one actually is going to be impossible, because if I can hit vertices 1, 2, and 3, maybe, but I'm not going to be able to get all 4. So that one is a big, fat no. And there's a reason why, but we don't know that yet. So let's take a look. Let's cruise on over to our next page and say, okay, here we go. This is where it's at. This is inscribed angles and circumscribed angles. So we've got a circle. We've got a quadrilateral inside of it. So now we're just seeing what has been done, what can been done, what has been done, and there it is. But the question is, that is a circle that is drawn around a quadrilateral, or as they say, circumscribed circles, which sounds kind of funny, because circumscribed circles sounds like circles drawn around circles. But it's actually, what we would call this is an inscribed quadrilateral. Quads. Biggest muscles in your body, in your legs. But these are all inscribed quadrilaterals. The quadrilateral's drawn inside of a circle, and there's something going on with the angles. So we're going to look at the questions, because it helps to read the question first. Let's draw an arc. Highlight from S to Q going through P. There's S to Q going through P. It's right there. Question is, what's the measure of that arc? Well, if you remember your inscribed angle theory from lesson 2 or 3, that inscribed angle should be half of the arc. So that would be 105 times 2, which would be 110 degrees. And if you know your circular geometry, the other arc is what's left. So 210 minus 360 would give me, oops, wrong pen, would give me over here 150. And now I can take a look and say, well, wait a minute, if that arc going across that way is 210, that means the angle is 105. We'll go in the other way. That angle right there should be half of 150, so it should be 75. And you'll notice something here. The 210, half of that is 105. Half of 150 is 75. Well, half of both of them, if you add them together, that 105 and 75 adds up to, wait for it, 180. Let's look at another example here just for a little more experience. That 62-degree angle, if I look across here at the arc, that arc's got to be 62 times 2, which is 124. That means the rest of the arc going the other direction has to be 360 minus 124, or 236. Now if I take half of that arc, remember, inscribed angle is half the arc. 236 divided by 2, I'm going to use a calculator because I'm lazy. Actually, I'm not. I just want to be accurate. 118. Now I got something interesting. 118 plus 62 is still 180. So here's the rule. The rule. Bottom line, if you will. The two opposite, inscribed angles, those are inscribed angles, are supplementary, or they add up to 180 degrees. The word is supplementary. So, right over here, on the left, I know I'm saying on the left, but you can't see me, so I'm over here on the left. That means that angle alpha plus angle beta is equal to 180 degrees, and that's always true. And that, folks, is the lesson in 7 minutes and 50-some seconds, except for one last piece. There's a quadrilateral. There's a word for this. It's called cyclic. Cyclic. Not sick COVID-19, but cyclic quadrilaterals. They're quadrilaterals where the two opposite angles are always supplementary. All right, 8:15, and there's a summary. Go ahead and read it. There's your vocabulary. There's your words. There's your figures. Check it out. Peace out. Later. Or as Forbes says, later.